In today's tutorial, we're going to talk about MultiSig contracts, what they're used for, and how to code one up and deploy it to the Tezos blockchain. MultiSig stands for multi-signature contracts for short. It's basically a smart contract that allows multiple people to participate within the contract. For the contract to execute a piece of code, it's going to need the signature of multiple signers or multiple participants. One way to use a multi-sig contract is that it can be used for governance. So multi-sig contracts can be used for governance, and they can be used by DAOs or Decentralized Autonomous Organizations to manage a treasury. So if you have an organization where they would need to frequently send funds to some other organization, you could have a multi-sig where participants of that multi-sig would need to sign the contract before funds can be moved to another organization. So that is one way to use a multi-sig. Another application of a multi-sig is for security reasons. So if you've got money or if you got tokens in a ledger or in a wallet, you want to avoid the situation where if someone gains access to that ledger or to the private keys for that wallet, they can move the funds. You could have the funds stored in a multi-sig that would require the signature or the private keys of multiple participants in order for the funds to be transferred out of that multi-sig wallet. So that's another application of a multi-sig. So today we'll be building a multi-sig contract, and in our multi-sig contract we would essentially have 4 participants, and we're going to need 3 of those participants to vote on a proposal in order for funds to be transferred to a receiver. Let's take a look at a diagram that explains what we're going to be doing today. So we're going to have a smart contract right here, as you can see, and the smart contract is going to basically allow someone or one of the owners or one of the participants of the multi-sig to create a proposal, and that's step 1. So in step 1, one of the owners or one of the participants of the multi-sig creates a proposal, and once that proposal is created, other participants can vote on that proposal. And so we would have participant 2 or owner 2, owner 3, and owner 4 also vote on that proposal. And in this diagram here, we only have owner 2 and owner 3 voting for the proposal. By the time it gets to owner 4, once the required number of votes are met, we do not need owner 4 to vote anymore. Once the required number of votes are met, the smart contract is going to transfer the test to the receiver, who then claims the amount. So this is what we're going to be building today. Now let's get into the code. We're going to be coding this up in SmartPy, and I love to use the SmartPy IDE. It's a brilliant tool to use to code up your smart contracts in SmartPy. So head over to the SmartPy IDE at smartpy.io/IDE, and let's code along. So the first thing that we need to do is we need to bring in the SmartPy Library, and that's where we start off. And then we define a module so that SmartPy knows that we're writing a SmartPy module. And first, we're going to define a type for our proposal, right? So we want to be able to ensure that we're controlling the types. We want to be able to make sure that whatever data that we're passing into our contract is type checked to avoid errors when the contract is deployed or when the contract is originated. And the kind of proposal type that we want an integer, right? So we want the key to be an integer, and then we want a type of record to take the payment amount. So the payment amount is the amount of Tez that we're going to be sending to the receiver. We also want the receiver's wallet address, so we can know exactly where the money should go. We also want to know the voters for that proposal. So we want to know the wallet addresses of everyone who has voted on that proposal. And lastly, we want to be able to determine if voting has been completed for a particular proposal, and this is going to take a type of Boolean, which is either true or false. Next, we define our class, which we're going to call MultiSig contract, and this is going to inherit from the contract class of SmartPy. And then we can start off by initializing our method. And our method here is going to take in, when we originate our contract, we're going to have to pass members to it and required votes. So members is basically the wallet address of everyone who can vote in this contract or who can participate in this smart contract. And required votes is the number of votes that we require for the contract or for the proposal to be executed. Now, the first thing is we want to keep track of all of the proposals submitted to the multi-sig, and we're going to cast our proposal type. We're going to cast our self.data.proposals, which is basically our storage on the blockchain where we store all of the proposals. We're going to cast the type of that to proposal type. So remember, we already defined proposal type up here. And essentially what we're doing is that we're ensuring that whatever data is being passed to proposals matches this proposal type. And the next thing that we want is we want to be able to keep track of which proposal is actually active. And to keep track of that, we're going to have an active proposal ID. And next step is we want to keep track of all of the members of our MultiSig on the blockchain. And we're going to cast that type as well to a type of addresses. And then required votes is going to be a type of natural number on SmartPy. And next, we are going to create our first entry point. And our first entry point is the deposit entry point. So this entry point is going to allow users or members of our MultiSig to deposit funds into this smart contract. And the first thing is that we check if the user or the wallet trying to deposit funds into the smart contract is a member of the MultiSig. And if it is, or if the person is, we allow the transaction to go through and they're able to deposit money into this smart contract. And then the next entry point is the submit proposal entry point. So this entry point would allow participants of our MultiSig or members of our MultiSig to be able to submit proposal to the MultiSig. And as always, the first thing we're going to do is to check if the person calling the contract is a member of the MultiSig or not. And we're using assert for that. So assert checks if the sender, so this is a SmartPy method that gives us the sender's address. We check if the list of members that we've got that is stored on the chain contains the sender's wallet address. So the sender of this, or the person signing this transaction, we check if their wallet address is contained in our members set or storage. And if they're not a member, we display not a member of MultiSig as the error message. The next thing that we need to check is if the payment amount is less than sp.balance. For this line, if the payment amount required in this proposal is greater than sp.balance, we're going to display a message saying the MultiSig does not have enough funds for this proposal. So we always want to make sure that whatever amounts that a user is submitting as a proposal for the amount that needs to be transferred to a receiver, it needs to be less than what we've got in the contract's balance. So sp.balance gives us access to the contract's balance. And then the next thing is that we increment the active proposal ID by 1. And finally, we actually pass all of the information for the proposal. So we pass the payment amount, which comes from params. We also pass the receiver address as well. And then we automatically assume that whoever is submitting a proposal is also voting on the proposal as well. So we add the sender's address to the list of voters. And then voting complete, of course, is false because the voting has not been completed yet until we have at least 3 people vote on this proposal. Now, once that is done, our next entry point is the vote on proposal entry point. And the first thing again, we check if the sender of the transaction is a member of the MultiSig. And if they are, we continue executing the function as normal. And we check if they've also previously voted on the proposal as well. So we check if the user has voted on the proposal. Let me expand this. So if the user's wallet address is found within the voter's storage, we're going to display a member has voted on this proposal error message. So remember that up here in our storage, in our proposal type, we define voters. So every proposal will always have a list of voters connected to it. And if you voted previously, we're simply going to deny you the chance to vote again. And if you've not voted, this will continue executing as normal. Yes, and if you've not voted, we basically take your wallet address and then we add you to the list of voters. Remember that when you call this entry point, you're going to call this entry point every time a user tries to vote on this proposal. And at the point where we have the required number of votes to execute the proposal, this is the point where we send the funds to the receiver. So this check that we do here is to check if the number of voters that we have recorded on chain is equal to the required votes that is needed. So required votes, remember that is always going to be passed on when the contract is being originated. And then this array or this list of voters, if we get the length, we'll be able to tell how many people have voted. And we check if that is equal to the required votes for this proposal. And if it is, we simply call the sp.send method. We pass in the receiver's address, and then we pass in the payment amount, which is the amount that we want to send to the receiver. And we also mark the proposal as completed. So we mark the voting complete, we set it to true, just to say that the voting has been completed for this proposal. Now, once all of that is done, the final step is for us to start to write our test. First of all, we give our test a name, which is MultiSig. We define a test method, and we create a scenario, and we define a couple of test accounts. So we're going to have Alice, Bob, Charlie, and Danny. And we're also going to have one more account called Errol as well. And let's create a scenario. So in scenario here, we're going to call it MultiSig proposal contract. And the reason why we're using H3 here is because this is basically displayed as an HTML in the output panel. And you'll see that as we go further. Now, the first thing that we want to do is we want to put 4 members in our MultiSig, right? So we're going to pass, we've gotten the address of Alice, of Bob, of Charlie, and of Errol, and they're all in a set. And then we initialize our contract. And when we initialize our contract, it takes in, remember, it takes in a list of the members, and it also takes in the required number of votes to execute the proposal. And so we're going to pass the members that we have here, which is these 4. And we only require 3 votes for the proposal to execute. We're also going to pass that number in there as well. And next, we're going to merge our scenario and contract together so that it can execute. And then the first thing that we're going to test for is that members or anyone who is a member of this MultiSig can actually add funds to the contract. And we're going to call the contract.deposit entry point. We're going to pass the sender of the transaction as Alice. And we're going to pass the amount of Tez to send to the contract, which is 50 Tez. Our next test is going to be that members can submit a proposal for funds to be sent to an address. So if you want to send funds to a receiver, for example, or if you want to submit a proposal to this contract, this is what this scenario is going to be testing. So we call the submit proposal entry point. We pass the record in, or we pass the type of record in, the payment amount, which is 30 Tez in this case. We pass the receiver's address, which is Danny, and then the person sending this transaction is Alice. Or the person submitting this proposal is Alice. Now, the next thing that we're going to test is that non-members cannot vote on proposals. So if Danny, for example, is not a part of our MultiSig contract, so he's not a member of our MultiSig contract, we're going to test that Danny cannot vote on this proposal. And then we're going to check that all the other members can also vote on the proposal. And once we're done with that, we want to make sure that our contract balance is 20 Tez after we've transferred 30 Tez up here to Danny. And we call the scenario.verify method, which would check that our contract balance is at 20 Tez. Then we'll also check that a new proposal can be created. And we check that when you call the submit proposal entry point and pass in more information, and that's also sent by Alice again, we want to make sure that Alice can actually create another proposal. And then this new proposal can be voted on. So we check that Charlie can also vote on the proposal. And yeah, let's see if all of this works now. So I'm going to expand this a little bit just so that we can see more of the data. And I'm going to hit run code. And once you hit run code, you can see the original balance for the smart contract starts at 50 Tez. Remember that that's our first thing that we're doing here. We're calling the deposit entry points, making sure that Alice can deposit funds into the smart contract. And that works correctly. You can also see all of the things in our storage. For proposals, we expect key payment amounts, receiver, voting complete. You can see required votes, which is 3, which we already said. And these are the wallet addresses of the 4 members of our MultiSig contract. Now, the first test. So we've tested now that members can add funds to the contract. The next thing is that we want to test that members can submit a proposal for funds to be sent to an address, right? So you can see here, we call the submit proposal entry point. And remember that we passed the payment amount and we also passed the receiver. So we've passed 30 Tez as the payment amount and we've passed Danny's address as the receiving address. And you can see here, 30 Tez has been passed in the submit proposal entry point and the receiver is Danny's wallet address. And as you can see, whoever is submitting the proposal automatically becomes the voter on the proposal. And this is the address for Alice, who is the sender for this transaction. And of course, voting complete is going to be false because this proposal has not been completed yet. And our required votes still remains 3. We want to make sure that no members cannot vote on proposals. And as you can see here, when we call, let's go here. So when Danny is not a member of the MultiSig, as you can see, we only have Alice, Bob, Charlie, and Earl. Danny is not a member of our MultiSig, and when Danny tries to vote, he's going to get an error saying not a member of MultiSig. Now we want to make sure that all of the other members can also vote on the proposal. So we basically call the vote on proposal entry point, and we pass in Bob's address and Charlie's address, and we see that all of that works correctly, all of that works fine. Remember that when Alice submitted this proposal, she automatically was counted as a voter for the proposal on the MultiSig. Now that we know that Alice has voted on the proposal because Alice was the one who submitted the proposal, we've now called the vote on proposal entry point with Bob's address and with Charlie's address. We've now met the required number of votes for this proposal to execute. And as you can see here, member 3 can vote on proposal, which is already tested. And once member 3 votes, you can see operations here, and Tezos is being transferred to this wallet address. And if we check here as well, we can see the receiver. We can see that we've got 3 voters now. Voting complete has been set to true, and the required votes, which is 3, which is also what we have here, 3 voters. And this is the key for our proposal. So this is the first proposal that we have on the queue. Now, once all of that is done, the next thing that we wanted to test is that our contract balance should drop to 20 Tez after transfer, which it did, or else our test would have failed. And then we also want to check that a new proposal can be created. And as you can see here, we have a new key for our proposal, which is 2. Payment amount is 20 Tez this time around. We have the receiver's address. Remember again that once you submit a proposal, you automatically become a voter on that proposal. And that's why we have this address here as well. And again, voting complete is false. We check that other members of our MultiSig can also vote on the proposal. As you can see here, we have an additional voter can also vote on the proposal. And if I run this all the way to the end, you will see that at the end, this contract is going to, the proposal is going to execute, and the receiver is going to get their funds. And that's how you write a MultiSig contract that allows 4 people participate in the MultiSig, requiring only 3 votes when proposals are submitted. And once the proposals are submitted and they are voted on, most of the people within the MultiSig are in agreement. The funds get transferred to the receiving address. If you want to follow along with the code, or you just want to read the code for this MultiSig contract, click the link in the description below to follow along.